Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem 01 matrix. In this problem, we're given a n cross m matrix. That means n are the number of rows in the matrix, m are the number of columns in the matrix, and the matrix is a binary matrix. We have to return the distance of the nearest zero for each cell. Okay, and the distance between any two adjacent cells is 1. That means take any cells and all the cells around it which shares a side with this cell has a distance of 1 from it. Okay, let's see the constraints of the problem. The dimensions of the matrix goes up to 10,000 while the matrix contains either 0 or 1. Okay, and there is at least one 0 in matrix because that's what the question demands, that we have to find the distance of the nearest 0 for each cell. So if there is no 0 in the matrix, that means the distance for the nearest 0 for each cell would be infinite, and that would give me a no solution, and hence we have at least one 0 in the matrix. Let's better understand the problem statement using an example. We have a matrix of dimensions 3 cross 3. We want to find the nearest 0 for each cell. Okay, so let's take the first cell. In this cell we can see that the cell contains 0 in it, hence the distance for the nearest 0 for this cell is 0, and same goes for the cells which contains zeros. This and this, they all have distances as 0, while this cell has a distance of 1 because the cell to the left of it has 0, the cell to the right of it has 0, and the cell just above it contains 0. Hence the nearest 0 from this cell has a distance of 1. That means we have to make just one move to reach a cell from this cell which contains a 0. Okay, so that's why we have 1 here. Then we move to this cell. Same is the case for this cell. We have to make only one move to reach the cell which contains 0, hence we put 1 here. Then for this cell we again have to make only one move to reach this cell, therefore we have 1 here. But for this cell we have to make two moves: move right, then move up, move left, move up, then move, and all the rest of the zeros are 3 steps away from this cell. So the nearest 0 is 2 steps away, or the distance of the nearest 0 from this cell is 2, hence we put 0 here. Okay, so this is the output matrix for this input matrix, so that we have to return. Okay, so I hope you got the question what it is asking. Let's try to build the solution using this example. So this is the matrix of dimensions 3 cross 3, and we want to find the distance of nearest cell which contains 0 for each cell of the matrix. Now you can see that, okay, so here you can see that each cell which shares a side with this cell is at one distance away from this. Okay, so let's call this cell 1. So we have 1. This is a node. So I'm trying to represent this grid as a graph. Okay, let's see how it will simplify the thought process. So this is basically the first node, then this node is at distance of 1, let's call it 2. So this is the node number 2. This is node number 3. It is again at a distance of 1, node number 3. Here you can see that what I am doing here, I'm representing this grid as this graph. So let's say if this is node number 1, this is node number 2, and this is node number 3, then these nodes are connected to each other like this. One is connected to 2 with an edge, and one is connected to 3 with an edge, and the edge has a weight of 1, because this basically represents that all I have to do is I just have to make a move of 1 to move from this cell to this cell. Okay, and they are connected by direct edge, and all we have to find that what is the nearest distance from what is the nearest cell which basically which contains a 0 from this. That's all we want to know for each cell. So for each of this node we want to find the shortest distance node which contains a 0. So this contains 0, this contains 0, this contains 0. What I can do here to find that, I can just perform a BFS. So why a BFS? So this is basically a graph. This represents a unweighted undirected graph. So it's an unweighted undirected graph, and we want to find the shortest path from each node to the nearest cell which contain to the nearest node which contains 0. That's the task now. For that we would use BFS. So why BFS? Because BFS is used to find the shortest path in an unweighted undirected graph, and what it claims that first time a node is discovered, that distance from the source would give us the shortest path, hence the shortest distance. So if I start from node A, okay, so that's why I would use BFS. But what will be the source nodes for performing this BFS? That's the question. Now you can see that in this grid all we want to do is we want to find the nearest cell to this node, which like the cells which contains non-zero values. All we want to do is to find the nearest cell to this to the cell nearest cell to these cells which contains non-zero value. For that I can simply start BFS from the nodes which contains 0, because if I start the BFS traversal starting from those nodes, and let's say I reach this node, and the distance to reach this node is 2, and that also represents the nearest distance to reach this 0 from this, because the graph is undirected. So that's why, because the graph is undirected and we can move both ways, from 0 to this cell, from this cell to 0. Hence we would start our BFS from all the cells which contains 0. So as we know, in BFS we use a queue and we initially push all the cells which contains 0. So we push 0 0 0 1 0 2 1 0 1 2, and these cells I push in my queues. Let's see how I can perform the BFS traversal in my matrix. Okay, so the idea is simple. I take in the matrix, this is the function which performs the BFS, which basically gives me this updated matrix. So what I am doing in the first step, I'm calculating the dimensions of the input matrix, namely the rows and columns. This is a direction array. It is used to move in the 4 directions, up, down, left and right, and that's why we are using this array. This is a queue, so we are declaring an empty queue, and in this queue I will push all the cells which contains 0. So these cells I will push in this queue. Here, this is my queue right now, it contains these cells. Okay, and those cells which contains non-zero values, I will assign -1 to these cells. The fact that I am assigning -1 will be explained in the next. Okay, so I'm iterating over all the rows, iterating over all the columns, hence all the cells of the matrix, and pushing the. Okay, so here I'm starting the BFS traversal. Okay, this is the standard BFS traversal. While the queue is not empty, I am iterating over all the elements in the queue, and I am basically extracting the top value of the queue from the front. And here what I am doing is that I am moving starting from the cell. So initially I take out this 0 0, so this cell basically I am pointing initially, and I want to move in all the other 4 directions. So I want to move here, because this direction is invalid since I am going out. So I will move in this cell and this cell, and I will check, and that I am using this direction array which I declared there. Okay, so this direction array basically gives me a direction towards which I am moving. So here you can see that I can move only right and down, so that I am checking here. So these are the conditions, boundary conditions, and this is the condition where I am checking, okay, if the cell where I am moving, if it does not contain -1, that means it contains 0, hence continue. That means this is not the cell which we want, okay, which we want, to which the distance we want to update. Okay, otherwise if the cell do contains -1, then what we do, we basically update the distance of that cell by 1. Okay, and we know that this cell is one step away from this cell, and hence I'm adding 1 here. And since this cell does contain a non-zero value, so I push this into the queue. So that's how this code is working. Okay, so let's discuss the time and space complexity for this problem. So here's the time and space complexity. We know that we are traversing over each cell in this while performing this breadth first search. So hence, and there are n into m cells, therefore the time complexity is big of n cross m. And since we are using an auxiliary, using an extra queue to store our cells, the maximum space that this queue can take is also n cross m, because in the worst case we may store all the cells into the matrix in case all the cells contains 0. Hence the space taken in that case would be n cross m, and that is the time that is the space complexity for this code. Now, so m cross n is the time complexity. Okay, so that's all for this video. Let's see the code implementation of the solution. Okay, so this is the solution in C++. So what we are doing here is we are using this function is basically updating the matrix that we are passing here. So here we are computing the dimensions of the given matrix. This is the queue that we are declaring, and this is the first step where we are basically marking those elements which contains non-zero values, and we are pushing the cells in the queue which contains zeros. And then we have this then we have this while loop which is performing the breadth first search from all the cells which contains 0. So this basically in other words, this can also be said as that this is a all source shortest path problem. Okay, so let's see the code in Java. So this is the code in Java language, and this is the code in Python language. Okay, so it can also be said that this problem is all source shortest path problem, where all we had to do is to just find the shortest paths from all the cells which contains zeros. Okay, so that's all for this video. Thank you so much for watching the video, and stay tuned for more such updates.